Structure and preparation of benzene. Now, first let's see what are aromatic hydrocarbons. Aromatic hydrocarbons can also be named as arenes. So, arenes or aromatic hydrocarbon means the same. And most of the aromatic hydrocarbons contain benzene ring in it. And you know that benzene ring is highly unsaturated. And you know the structure of benzene. There are 3 double bonds. So the benzene ring is highly unsaturated. But in majority of the reactions of the aromatic compound, the unsaturation of benzene ring is retained. Now, these aromatic compounds, if they contain benzene ring, they are called benzenoids. So, if the aromatic compounds contain benzene ring, they are called benzenoids, and if they do not contain benzene ring, they are called non-benzenoids. And the word aromatic is given because this benzene compounds, they have a characteristic order. So, they are given the name aromatic hydrocarbons. Okay, so the term aromatic hydrocarbons can be given to compounds which contain benzene ring, and also we can use the word benzenoids if they contain benzene ring. Now, you know that all 6 hydrogen atoms in benzene are equivalent. So, they form only one type of monosubstituted product, because if you replace any of the hydrogen atom in benzene, we get the same compound. So, we get monosubstituted product. Now, when 2 hydrogen atoms in benzene are replaced by either same atom or different atoms or groups, then we get 3 different position isomers. Okay, so if we replace 2 hydrogen atoms in benzene by same atom or a different atom, we get 3 different position isomers. And we know the 3 different position isomers are ortho isomer, meta isomer and para isomer. And you know the position. Ortho position is 1, 2 or 1, 6. Then meta is 1, 3 or 1, 5, and para is 1, 4 position. Okay, now let's see about the structure of benzene. So next is structure of benzene. Now, it was found that benzene is a stable molecule and they form triozonide, which indicates the presence of 3 double bonds. So, we know how is an ozonide formed. Ozonide is formed by the reaction of ozone molecule. So, benzene forms triozonide, which means there are 3 double bonds. And also, benzene is found to produce only one monosubstituted derivative, which shows that all the 6 carbon atom and 6 hydrogen atom in benzene are identical. Okay, so all carbon, 6 carbon as well as 6 hydrogen is same. So we get only monosubstituted product with benzene. Now we have a structure named by Kekulé called Kekulé structure of benzene. So let's see what is the Kekulé structure. And you know the molecular formula of benzene is C6H6. Now Kekulé gave an explanation like this. He proposed that benzene has a cyclic arrangement of 6 carbon atoms with alternate single and double bonds and 1 hydrogen atom attached to each carbon atom. So he gave the structure for benzene as 6 carbon atoms. So we have 3, 4, 5, 6 carbon atoms. Then there are alternate single and double bonds. So double bond, single bond, double bond, single bond, double bond, single bond. And each carbon is attached to hydrogen. So this is the structure of Kecule structure of benzene, or bone line notation you can write like this. Okay, and each junction is CH with alternate single and double bond. So this is the structure of Kecule structure of benzene. Now next let us discuss about the resonance and stability of benzene. So next we have the resonance. We know that there are double bonds inside the benzene ring. So these double bonds are pi electrons. They can shift their position. So resonance is possible in benzene. So we have two main contributing structures for the benzene. That is one structure. The contributing structures are, this is one structure. Now the next resonance structure is, change the position of the double bond, so we have this. So these are the two contributing structures of benzene. Now the resonance hybrid structure can be shown like this, that is the hexagon ring with a circle inside. Okay, and the circle represents the 6 pi electrons. We know that there are 3 double bonds and one bond means 2 electrons. So we have 6 pi electrons which can be delocalized between the 6 carbon atoms of the benzene ring. So the circle inside this hexagon denotes the 6 pi electrons which can delocalize. Delocalize means they can shift their positions, change their positions. And now let's discuss about the hybridization in benzene. We know that in benzene the carbon atom, each carbon will undergo sp2 hybridization. So each carbon undergoes sp2 hybridization means each carbon there are 3 sp2 hybrid orbitals. Out of 3 sp2 hybrid orbitals, 2 sp2 hybrid orbitals on each carbon overlap with sp2 hybrid orbital of adjacent carbon atom. Now the third sp2 hybrid orbital of each carbon will overlap with s orbital of hydrogen atom, and we have in total 6 cc sigma bond, and also we have 6 CH sigma bond. Now there is an unhybridized p orbital on each carbon atom. This unhybridized p orbital will overlap sidewise to form a pi bond. So we have total 3 pi bonds present in benzene ring. And we know that the pi electrons can be delocalized and they can move freely about the 6 carbon atom. And the presence of this delocalized pi electron makes benzene more stable. And also from the resonance structure we can see that all the bond lengths, that is single bond and double bond lengths, are same. Okay, and that bond length is intermediate between single bond and double bond value. So these are the things for the structure of benzene. So benzene is a stable molecule due to the presence of 6 pi electrons which can be delocalized. And there are 2 main contributing structures for benzene, and benzene can be shown as a resonance hybrid of this structure. Now next let us discuss about the preparation of benzene. Preparation of benzene. Now there are mainly 3 methods for the preparation of benzene. The first method is cyclic polymerization of ethyne. Now actually here we have total 5 conversion questions. That is, how will you convert alkane to benzene, alkene to benzene, alkyne to benzene. Then next we have benzoic acid to benzene and also phenol to benzene. So 5 conversion questions. So first I am going to discuss about conversion of alkane to benzene. So the first method is alkane to benzene, means hexane, normal hexane to benzene. This we have already discussed under alkanes, that is the property, that term is aromatization. So I want you to refer this aromatization under alkanes, that is convert hexane, normal hexane to benzene, that is aromatization. Now the second is to convert ethene to benzene. So second method is convert ethene to benzene. Now ethene to benzene, we have not learned any properties under ethene for the conversion into benzene. So I am going to show how to convert ethene to benzene. First, ethene can be converted to ethyne, and from ethyne you can prepare benzene by cyclic polymerization. So how to convert ethene to ethyne? I am going to write the steps. Ethene is CH2 double bond CH2. Treat with bromine in CCl4. You will get BrCH2. The double bond breaks and bromine adds to double bonded carbon. Now, next you are going to remove hydrogen bromide. How to remove hydrogen bromide? By treatment with alcoholic KOH and heat minus HBr. Now, when HBr is removed, hydrogen can be removed from this and bromine from this. So, we get CH2 double bond CHBr. Now, next you treat it with sodamide and liquid ammonia. This reaction you have learned under alkenes. To convert this alkene into alkyne, you get ethyne as the product. Now next is cyclic polymerization, which is done using red hot iron tube. At 873 Kelvin, you get benzene as the product. So this is the conversion of ethene to benzene. First convert ethene to ethyne, followed by cyclic polymerization, that is passing ethyne through red hot iron tube at 873 Kelvin. We get ethyne. Now the third method is the conversion of alkyne to benzene, that is convert ethyne to benzene. So let's see how to convert ethyne to benzene. Third one. Number 3 is ethyne to benzene. So the step is the same, that is cyclic polymerization of ethyne. That is 3 molecules of CH, triple bond CH. Pass it through red hot iron tube at 873 Kelvin. You get benzene. Now the next is preparation of benzene from benzoic acid. So here we use the decarboxylation of benzoic acid. Now here you can use any aromatic acid. I am going to show the example with benzoic acid. So the third method, not third, fourth method is convert benzoic acid to benzene, and the method is decarboxylation of aromatic acids. Here the aromatic acid taken is benzoic acid, and you have learned the decarboxylation of aromatic acids under alkane. So I am going to write the example, that is from benzoic acid. How to convert benzoic acid to its sodium salt? First, treat benzoic acid with sodium hydroxide. You get sodium benzoate. This is sodium benzoate. Now treat the sodium benzoate with soda lime or heat with soda lime. We get benzene. So the next step is sodium benzoate, COONA plus NaOH. Soda lime is calcium oxide and NaOH. So what will be the product form? We get benzene plus sodium carbonate. Benzene plus sodium carbonate, heat also. Now you can see Na2CO3 plus benzene we get as the product. Okay, so that is our fourth method for the preparation of benzene. That is from aromatic acid, which is benzoic acid. Now the last method for the preparation of benzene is from phenol. So the last question will be convert phenol to benzene. Now phenol is reduced to benzene by passing its vapors over heated zinc dust. So I am going to write the equation: phenol plus zinc, heat, you get benzene plus zinc oxide. So here we have the reduction of phenol with zinc dust, we get benzene. So these are the 5 methods of preparation of benzene. From first method was from normal hexane aromatization, second is from ethene, third is from ethyne, fourth is from benzoic acid, and the last is from phenol. Phenol on reduction with zinc dust, we get benzene plus zinc oxide. So with this we complete the structure and preparation of benzene. Thank you.